One of the Istio's or service mesh core capabilities is to control how services communicate without modifying the application code itself. This concept is called traffic management. It allows you to do things such as A/B testing, Canary rollouts, rollbacks, and more. The two core API objects for traffic management are virtual service and the destinations rule. The destination rule is for the owner of a microservice. What versions do I expose and what happens to traffic before it reaches my service? The virtual service is for the client of a microservice. For example, how do I want to route traffic to the microservice? Let's take a look on the destination rule of user profile. In this example, it has three versions of user profile being configured: version 1, version 2, and version 3. Let's look at the virtual service of user profile. The traffic is routing to version 1, 100%. Let's start with a Canary release of the new versions of this user profile service. We will route 90% of the user traffic to version 1 and 10% of the traffic to version 3. By doing this, we can isolate the new user profile experience for a small subset of the users without impacting everyone at once. Let's save these configurations. Let's go back to the graph. Let's turn on the traffic animations and also the traffic distributions. So we can see the traffic is going to both version 1 and version 3. Now we are comfortable with the new changes. We can increase the traffic load to the new versions, which is version 3. We can change it to 50-50. Finally, if you are ready to roll out the new versions to everyone, you can change it to 100. And your profile will always show the version 3 background color. Next, I want to show you how you can test your application's behaves when a failure occurs. You can simulate these failures using service mesh. This concept is more generally known as chaos engineering. It still provides ways to inject failure at the application layer with abort faults and delay faults using virtual services. Let's start with the abort faults. We will take the virtual service of user profile. This configuration tells service mesh to inject 503 errors into 50% of the traffic sent to the user profile service. From the graph, you can see some traffic slowly going into showing the error, which is returning 503. If we look at our applications, we will sometimes hit error because the user profile service is not available and it is showing unknown user. Next, let's simulate a delay fault service. Let's go back to Istio config, look for the virtual service of user profile. Here, I'm going to change to delay and the fixed delay to be 5 seconds. This configuration tells Service Mesh to inject a 5-second delays into 50% of the traffic sent to the user profile service. Let's save it. To see the delay of the response times, we can go back to the Jagger UI. Let's do a find traces. Here we can see some services are completed within milliseconds, and we have some services that is taking 5 seconds to complete because we have set 5-second delay for the 50% of the traffic. Next, how do you protect a service if it has overloaded or failing instances serving the traffic? Ideally, you would like to identify an instance that is failing and prevent clients from connecting it. This concept is called circuit breaker. You set threshold limits for instances that run a microservice, and if the threshold limits are reached, the circuit breaker trips and it still prevents any further connection to that instance. A circuit breaker rule has already been prepared for this demo. This circuit breaking rule is only applied to version 3 of user profile service. The connections pool settings restricted the maximum number of requests to reach instance to 1. The outliner detection settings define the threshold. An instance that fails once with 503 error is ejected from the mesh for 10 minutes. Let's look at the virtual service of user profile. Here we can see the traffic is routing to both version 1 and version 3. Next, I'm going to scale down the user profile version applications to simulate the failure of this version 3 application. If we go back to the Canary graph, we should start seeing the percentage of traffic directed away from version 3 to version 1.